All right. So moving on to section 3.9. 3.9 deals with the derivatives of inverse trigonometric functions. So first thing as I look at this, and I don't have these memorized, all of these can be derived through mathematical proofs, but really the best thing is to be able to call out theorem 3.22 and know what some of these are. So like on theorem 3.22, first and foremost, theorem 3.22 basically gives us the derivative of any function inverse sine of x. So it basically tells us that that is equal to 1 over the square root of 1 minus x squared. So that actually becomes, at that point it becomes fairly trivial. The thing that we got to recognize on a problem like this is this really represents our x, is what's going on. So if we want to take the derivative of the inverse sine of the natural log of x, all we got to do in this case is replace that x squared down there by what we're working with now. Two things on that though. There's actually something we're missing here too. This right here actually does represent something else. Hopefully most of you guys have seen this already. That also represents a chain rule. We've got a function, the inverse sine of x, but instead of it just being like the inverse sine of a number, it's the inverse sine of another function, the natural log of x. So that really represents the f of g of x. So we need to do the derivative of the outside, f prime of g of x, again leaving our inside alone, times g prime of x. So that's what we're looking at to do in this case. And so let's think about the derivative of the outside, leave the inside alone, does go back to this scenario right here. So derivative of the outside, leave the inside alone, is going to become this derivative of the outside, 1 over the square root of 1 minus the natural log of x squared. So that just substitutes in for that x term. And then we need to take and multiply that by the derivative of g of x, or g prime of x. And as we know from previous, the derivative of natural log of x is 1 over x. And so our derivative in this case is going to be 1 over, and I'm just going to write this as x square root of 1 minus the natural log of x squared. That's my derivative right there. So hopefully the key on this again, representing, this whole section's about what these are, but then also representing or recognizing this chain rule right here, so we can work this problem.